We are now going to talk about the most famous operon. Lac Operon is a cluster of structural genes that switched on together by being transcribed from the same promoter. Francois Jacob together with Jacques Monod originated the idea that control the enzyme levels in all cells occurs through regulation of transcription. They shared Nobel Prize in Medicine back in 1965. The Lac Operon consists CRP protein binding site, promoter, operator, and 3 structural genes, where Lac Z encodes for beta-galactosidase, Lac Y encodes lactamase, and Lac A encodes for transacetylase.
When lactose is absent, the Lac repressor binds tightly to the operator. It gets in RNA polymerase's way, preventing transcription. When lactose present, the isomer allolactose will binds to the Lac repressor and makes it let go of the operator. RNA polymerase can now transcribe the operon.
So now, let's talk about global regulator. Example of global regulator is cyclic AMP receptor protein, which also regulatory protein in bacteria. CRP protein binds CAMP, which causes a conformational change that allows CRP to bind tightly to a specific DNA site in the promoters of the genes it controls, then activate transcription. When glucose levels are low, CAMP is produced. The CAMP attaches to CRP protein, allowing it to bind DNA. CRP protein helps RNA polymerase bind to the promoter, resulting in high levels of transcription. When glucose levels are high, no CAMP is made. CRP cannot bind DNA without CAMP, so transcription occurs only at a low level.
When glucose present, lactose absent, no transcription of the Lac Operon occurs. That's because the Lac repressor remains bound to the operator and prevents transcription by RNA polymerase. Also, CAMP levels are low because glucose levels are high, so CRP protein is inactive and cannot bind DNA. When glucose present, lactose present, low-level transcription of the Lac Operon occurs. The Lac repressor is released from the operator because the inducer, allolactose, is present. CAMP levels, however, are low because glucose is present. Thus, CRP remains inactive and cannot bind to DNA, so transcription only occurs at a low, leaky level. When glucose absent, lactose absent, no transcription of the Lac Operon occurs. CAMP levels are high because glucose levels are low, so CRP is active and will be bound to the DNA. However, the Lac repressor will also be bound to the operator, due to the absence of allolactose, acting as a roadblock to RNA polymerase and preventing transcription. When glucose absent, lactose present, strong transcription of the Lac Operon occurs. The Lac repressor is released from the operator because the inducer, allolactose, is present. CAMP levels are high because glucose is absent, so CRP is active and bound to the DNA. CRP helps RNA polymerase bind to the promoter, permitting high levels of transcription.
Created using Powtoon.